Alright, let's get started. In this presentation, we'll look at an IoT-based multi-zone thermostat that can be controlled using Alexa. Primarily, I want to help demystify how Alexa works and thus potentially demystify any natural language processing service such as Cortana or Google Home, since at the core they all work very similarly. To start with, I'll demonstrate the IoT multi-zone thermostat device and controlling it with Alexa. And then I'll take you behind the scenes to look at the entire ecosystem that makes all of this possible. So what you're seeing here is the camera with the device that's hooked up to an emulator, and this emulator is emulating the actual HVAC unit in your home. That's Echo or Amazon Echo, and this is the power supply that typically would be, of course, in your HVAC unit, but I need it here to power up this board so that all of this works. When you connect this device to your home, you have these 5 wires here potentially that you need to connect this board to the wiring in your house. The wiring in your house also has the same 5 wires. They're typically color coded as red, blue, green, yellow, and white. The red and blue are the power. This is AC power, it's not DC, so don't mistake the red and the blue to be positive and negative. They're just AC. The green gets connected to your fan in the HVAC unit. The yellow goes to your air conditioner unit, and the white goes to the heater. Because you don't necessarily need to know that. You just color code and match the wires and hook it up. The PCB itself has, let me move this up here. The PCB itself has a onboard rectifier and regulator for converting this AC to a 5-volt supply that the microcontroller is driving off of, and then the rest of the circuit as well is running off of the 5 volts that's being produced by the regulation. None of that is necessarily relevant for this demo, since we're not digging into the details of the actual thermostat's hardware and software. What you're seeing here is the temperature that's on board the actual device itself, and the temperature setting for the specific sensor is here. The device is known as the family room device, as in, since it's typically in your family room, the wiring is in your home. Then this device has an onboard temperature humidity sensor as well, and what you're seeing here is the temperature and the humidity of the sensor. It's heating up a little bit because of the lights, or the heat from the lights. At this point, Alexa has been muted, so you're seeing her muted over here. The phone application, which is this one, is a UWP, in this case a UWP application that, it could be any application. I just happen to have a UWP application, so I can use the application for my Windows phone, but you could have made this in a web browser based application or just a desktop app. The settings here are the typical settings you would be controlling from your thermostat or of your thermostat, which is the mode, which can be off, cool, heat, or fan. The zone is, as I said, there's the different devices that are the active zone. These are the other zones here. So I have sensors in the master bedroom, in the study, and the living room, and some of them don't have a humidity sensor, and some of them do. So these two actually have a humidity sensor as well. So I'm displaying the humidity for the different zones, whereas these are just temperature sensors. So you have the ability to change the zone from, let's say, the family room to the master bedroom, change the mode from off to cool or heat or fan, and change the setting of the temperature to the desired temperature that you want for the specific room. So I'm going to unmute Alexa. Now from the phone application, you can do all of these. You can change all of these settings by going into here and then making the different settings and hitting the set button. So let me show you that. So let's say I want to turn on the fan. So the fan is sort of temperature independent, as in when you say turn on the fan just comes on irrespective of any temperature setting. And therefore this zone is sort of a moot point since the temperature and the zone are sort of tied together. So when I hit the set button, you should see the fan bulb turn on here to indicate that the fan has been turned on. There'll be a little blue LED that comes on here. Basically, anytime I turn on any of the devices, the hardware devices here, I turn on this LED light here just to indicate that the microcontroller is turned something on. You don't know which one. It's just the same blue light being used for all of them. The PCB here also has I2C bus exposed. The sensor is an I2C sensor. The nature of I2C is just that it's a bus that you can hook up multiple devices on the bus in parallel. I've just exposed two other, basically totally three I2C connections. So you can have an OLED display if you wanted to have a display for the board rather than rely on like a phone application or something to see the information, or anything else, some other sensors, or any I2C device for that matter. So now I'm going to hit the set button, and you should also see a notification appear here at the bottom of the screen, and I'll explain the purpose or why that notification came in the first place. So I'm going to hit set, and you saw the light come on. The mode got changed to fan, and you saw this notification. This notification is, of course, something I've programmed. Nothing to do with Alexa or even the thermostat for that matter, but it's something I programmed that in this case it says the air conditioner has been off for 31 minutes and 47 seconds. The zone is family room and the temperature is blah. And it tells you, it basically comes every time a device changes state. So the fan goes on or off, the air conditioner goes on or off, or the heater goes on and off. But of course it's just a notification, and in my case I've decided to send this notification out each time the state changes, but you're free to do what you want. So that's kind of how the device works, and the phone app can be used to control all the different features or settings of the device. But now let's show how all this would work with Alexa. So I'm going to unmute this. So let's say I want to turn the fan off. I would say, Alexa, ask thermostat to turn off the fan.
I've set the thermostat mode to off.
So the lights went off, the mode changed to off here, and the notification came saying the fan was on for 1 minute and 24 seconds. So let's say I want to change the zone. Alexa, ask thermostat to change the zone to master bedroom.
I've set the thermostat zone to master bedroom.
So it's changed to master bedroom here. The mode is still off, just the zone has changed, and now you're seeing the temperature in the master bedroom versus the family room. So that's 79 degrees here in the family room, mainly because of the lights that are heating up the sensor here. And so you can change various things, and there's various ways in which you can change things. That's what I'm going to demonstrate here using, won't take her name here. Alexa, ask thermostat for settings.
The current zone is master bedroom. The temperature is set to 67. The mode is off, and the heating and air conditioning is off.
So typically when the appliance is on, you'll see like an orange dot appear here, and of course on the hardware you'll see the blue light over there. But when she says the appliance is off, she's really saying that, or heating and air conditioning is off, she's really saying that there's, even though the settings are these, there's no actual appliance that's on or off. And that might be important for you to know in case you're not aware of the actual appliance being on or off. So now I'm going to ask her to turn on the fan again. Alexa, ask thermostat to turn on the fan.
I've turned on the fan.
And so now the device orange light shows up here, the notification comes in, and the fan's light is on. Alexa, ask thermostat to turn off the fan.
I've set the thermostat mode to off.
So now let's look at some of the other things you can do. So we saw changing the zone, we saw changing the mode to on, off, or off to fan. Let's see, changing the temperature. Alexa, ask thermostat to increase the temperature by 2 degrees.
I've decreased the temperature by 2 degrees.
Right, so even though I said increase, she's hearing it as decrease. And I've had this issue where she's not able to distinguish, maybe with my accent, the difference. I used different terms to do the same thing, and that sort of works. Alexa, ask thermostat to dial it up by 2.
I've increased the temperature by 2 degrees.
Right, so she's increased it by 2. So, it's up to you how you define the language model to indicate what action has to happen when you say certain phrases or certain utterances. So I could also say turn it up or turn it down. Alexa, ask thermostat to turn it up by 2.
I've increased the temperature by 2 degrees.
So now it becomes 67. The app is not necessarily displaying things in real time. There's like a 5-second interval for each of these sensors to be publishing their information. So this sensor, they're all independently publishing their settings every 5 seconds. And the setting information itself, it comes also in 5-second intervals. So they're all, this section here, each of them is publishing their own temperature every 5 seconds. This zone's temperature is being published every 5 seconds, and then this information is being updated every 5 seconds as well. So they're all very independent. So you see some sort of a delay, but by the time you get the response from Alexa saying she's done something, the device itself has got that message. Now let's look at some other features. Let's say I want to just turn on the air conditioner. Now there's 2 ways to say that. You could say, set the mode to cool. So that's one way to do it. You can say, Alexa, ask thermostat to set the mode to cool.
I've set the thermostat mode to cool.
So the mode gets changed to cool, but that doesn't necessarily mean that the air conditioner is going to come on, because after all, this is a thermostat. So it's been set to cool, but it determines whether it should be turning on the air conditioner or not based on this temperature. So now, because the temperature is the same or similar, it doesn't see the need to turn on the air conditioner. However, if I change the temperature or lower the setting here, then it'll turn on the air conditioner to try and get this temperature down to that setting. Alexa, ask thermostat to dial it down by 2.
I've decreased the temperature by 2 degrees.
So the moment she did that, the thermostat is sensing that, okay, I need to turn on the air conditioner to cool things down. The notification comes in here. The orange dot indicates the appliance is on. The bulb, of course, indicates the appliance is on. And in this specific case, this blue LED here is also indicating that this appliance is on. In case you're wondering here, this is actually an LED on the microcontroller that's kind of breathing, as it is going brighter and dimmer. You're probably seeing it as like a flashing thing here. Every 5 seconds it flashes orange to indicate it just transmitted some data. So that's when the data from here gets transmitted to the broker that's behind the scenes, and then that gets displayed here. There's another way to turn on and off devices. You could say, Alexa, ask thermostat to turn off the air conditioner. Alexa, ask thermostat to turn off the air conditioner.
I've set the thermostat mode to off.
And so, because the mode's been set to off, in this case, the air conditioner turned off. So you don't necessarily have to know whether the air conditioner was on or the heater was on. You can just say, turn off the heater or turn off the air conditioner. Off is off. So it's relevant what has to be turned off. And sometimes I've found that I want to say things slightly differently. Maybe when I want to just turn on the air conditioner, I sort of know that the zone is master bedroom and the temperature, let's say, is 67. That's my desired settings. So by just saying turn on the air conditioner, I may not really get what I want, because maybe the zone has been set to living room or the temperature is 72. So you can have another way to say all these things. You could say, Alexa, ask thermostat to turn on the air conditioner at 67 in the family room.
I've turned on the air conditioner at 67 in the family room.
So I was able to do all of those things in just one sentence. Like this is not magic, and we look at when we go behind the scenes what you have to do to make these different utterances be understood by Alexa so that she does the right, or she basically parses that information and figures out what is 67, what is the family room, as in is it a zone or is something else, and turn on or turn off the air conditioner or heater, how that all works. So I think I've done the Alexa aspects itself. I think that gives you a good idea of the kinds of things that are possible. You can change settings independently or change settings collectively. There's another way to change all of these at the same time, which is not necessarily the most natural, but it was one of the first things I had programmed, and it's still available, or still exists in the Alexa model, so I could say that in different ways. So most days during the course of using this thermostat and my interaction with Alexa, I found we typically just turn the heater on or off, or the air conditioner on or off. Sometimes we change the zone, like let's say in summertime, the upstairs gets quite a bit warmer than the downstairs. So you want to change the zone and set the temperature to one of the rooms upstairs rather than, let's say, the family room, which is downstairs and much cooler. So the upstairs is heating up. So you change zones, you change the temperature, and you change the more typically when we're not in the house, we just turn off the air conditioner, and then on the way to the house, or maybe if you're in the house, then at some point in the evening, just turn on the air conditioner because it's pretty pleasant outside. And the phone app kind of does the same thing. So this takes care of sort of the introduction and kind of demonstrating how you can control a device using Alexa. So let me just turn off the air conditioner here. Not that the actual air conditioner is on, since I've disconnected the board from the home wiring. Alexa, ask thermostat to turn off the air conditioner.
I've set the thermostat mode to off.
Okay, there are a few other things I forgot to demonstrate. So I can get the settings, and I can get something called status, which is pretty much all of this. Alexa, ask thermostat to get settings.
The current zone is family room. The temperature is set to 67. The mode is off, and the heating and air conditioning is off.
Right, so that's the settings. Now I can say ask for status. Alexa, ask thermostat for status.
The current zone is family room. The temperature is set to 67. The mode is off, and the heating and air conditioning is off. It is 69.57 degrees in the master bedroom, and the humidity is 49.8%. It is 80.06 degrees in the family room, and the humidity is 44.22%. It is 69.01 degrees in the study, and the humidity is 0%. It is 69.24 degrees in the living room, and the humidity is 0%.
Anyway, now you might wonder, when you ask for status, it's like takes a long time for her to give you all this information. Maybe you want to stop her mid-sentence, if you will. So you have that ability as well. Let me show you that. So I'll ask her for the status, and then midway through I'll just ask her to stop. Alexa, ask thermostat for status.
The current zone is family room. The temperature is
So
set
now
to
I'll
67.
ask her to stop.
Off, and the heating and
Alexa,
air
stop.
conditioning.
So now this is a feature that they have as part of the SDK, in the Alexa SDK. You do have to enable, or you'd have to, I guess, include it in your language model so that you can interrupt this.
I don't know that one.
Yeah, you don't. But that interruption then works across any of your intents. If that was the case, if something takes a long time, or she misunderstood something and she starts going off on a different tangent, then you can just say stop, and she'll stop. All right, now let's go behind the scenes. So this is the entire ecosystem here, and I want to try and demystify this ecosystem. It seems fairly complicated, but it's not. It probably is complicated when you first start out, but once you get to grips with some of these things, it's not that bad. And just to be sure, for the actual thermostat device to work, the bare minimum, at least to make it kind of usable, the bare minimum is, of course, the device that's plugged in or hooked up to the wiring in your home with its own onboard sensor. You need some application, since there's no display on board here and there's no buttons that you can press to change settings. You could do that. Of course, the hardware actually supports that, but this, in my demo, that's not the case, and I don't personally have a need for like an OLED display on the device itself. So for my purposes, I prefer using a phone app that works on my phone or the desktop or any other Windows device, and a MQTT broker to make it all work. So basically the device gets its sort of commands, let's call it, by subscribing to a topic in the broker, and the phone application will publish the settings that you want to change to that topic, and then the device responds to that, and vice versa. The device is publishing its status information to another topic, and then the phone device is the subscriber to that topic, so you see all the information here. When you have other sensor devices, these are sort of dumb devices, and in that all they simply do is publish their temperature settings to a specific topic. The device receives that information, and in this case the phone app also receives the information. The device receives the information because you might change the zone to one of those other zones. So in order for it to know the temperature of that zone and control do the function of a thermostat, turning things on and off as per the temperature in that zone, it receives those messages as well. So just like the phone app displays the other zones, the main device itself is able to receive temperature settings from other zones and then keep a track of these zones. And then when you say change the zone to X, it knows which zone you're talking about. MQTT stands for Message Queuing Telemetry Transport. It's a protocol that was introduced by IBM many years ago and was used essentially for industrial telemetry requirements, where industrial machinery talks to each other and you can control them. And recently, I think 2013, IBM sort of open sourced it and made it available, and it's now a standard. That's an open source standard, and therefore other manufacturers or vendors and hardware devices and software support MQTT. It's a pub sub or a publish subscribe broker similar to RabbitMQ and Service Bus, Azure Service Bus. It's, even though it can handle all the traffic, it's essentially intended for devices that are constrained devices, constrained in that devices such as these microcontrollers that have very limited memory and very limited CPU or microcontroller power, as in compute power. And so you're typically sending very small messages across the wire to the broker, and the broker then publishes it to any subscribers to those topics. All right, so let's look at some of the other parts and pieces here. So when you talk to, let me mute Alexa here. Okay. So when you talk to your Alexa device, essentially what's going across the wire to Amazon Alexa, so the cloud service, is an audio file. Literally an audio file is being sent across the wire to the Alexa service. And then in this service, the machinery, if you will, or the application or system is parsing out this audio file and trying to understand what was being said and extracting from that pieces of information that are relevant to, in this case, your application. So we define this model, and I'll show you how that works. And once you've defined the model, the audio file here is parsed, and then it tries to fit the parameters, if you will, the important things in the language that you spoke or the words that you spoke, to, let's call it, method calls and parameters. Once that's done, the application, the Alexa, Amazon's feature has the ability to publish to any HTTPS endpoint that information that comes in a large XML structure, and it needs to be an HTTPS endpoint that's publicly accessible. In my case, I'm using AWS Lambda, but you could use Azure Functions or any other endpoint. It doesn't have to be a function kind of endpoint or Lambda endpoint. It's just some HTTPS endpoint that gets this large XML structure with all that information in there, and then you can do what you want with that information. So essentially the mystery is really sort of sits here, because we can't understand how it goes from this device to an HTTPS endpoint. Once you're in the realm of the HTTPS endpoint, that's just a regular HTTPS endpoint, because you do need to know the XML structure and therefore how to extract out that information. Amazon has an SDK that does that for you. So if you're working with C# or Node.js, they have SDKs for these and other languages, Java as well, that essentially extracts that data out from the XML and provides it to you in the form of objects and properties and such. So in my case, I'm using Amazon Lambda, and I'm using Node.js in AWS Lambda simply because the Alexa SDK for C# is, personally, I don't quite like it. I don't care much for it. And you're dealing with sort of this dynamic world, if you will, the dynamic type in .NET. And I figured, well, if I'm going to be using dynamic, I'll just stick to Node.js, since that's dynamic and you're not getting confused with being a statically typed language with all the stuff that's dynamic. And I'll show you some of the code there. And then that Lambda function essentially publishes a message to a specific topic in the MQTT broker, just like the phone is doing when you change the settings on the phone. It's publishing to the same topic the information, so that let's call it the command topic. So both of them are just talking to the command topic, and of course the device itself is a subscriber to that command topic. So when it receives commands on that topic, it reacts. Because all you're really getting as far as commands are concerned is the setting data. That is what mode, what zone, and what temperature. The actual turning on and off of the device is completely dependent and controlled by the actual thermostat device, because it is a thermostat. So you don't have to tell it when to turn on the air conditioner per se. Even if you wanted to, it's not going to do that if the temperatures are not correct. In other words, if the set temperature is higher than the actual temperature and you say turn on the air conditioner, it won't actually turn on the actual air conditioner. Since it is a thermostat, it knows not to turn the air conditioner on. But what you've done, in fact, is set the setting, the mode from off to cool or from heat to cool when you say turn on the air conditioner. And so there might be a bit of a disconnect sometimes in what is this whole portion doing. Is just sending messages to the device to change the settings, not actually turn some device on and off, even though you could do that. The programming on the hardware device, the IoT device, is, of course, it's a thermostat, so it just needs to know the settings, and it knows when to turn on and off the various appliances. The other thing that's happening is when you ask Alexa for the settings or ask her for the status, because that comes through here as an audio file, it gets parsed to what we call intents in Alexa. So it knows the intent is get settings or get status. Comes into your Lambda function. The Lambda function makes a call out, or the Lambda function then becomes a subscriber to a topic that this device is publishing its information to. So there's another topic where this device is publishing information, which is the same topic that the phone app is subscribed to receive that information. So when you ask for the settings, the Lambda function is temporarily a subscriber to the same topic. So it might have to wait, at least that 5-second period to receive the latest status, and then it returns. I have a case here where the topic in question persists that information for a certain period of time, and so therefore when the Lambda function goes out to this topic to read the current status, potentially you could be getting status that's 5 seconds old instead of the current status, which is at least for this application or this purpose, it's fine. What's 5 seconds in the scheme of things? So it's not like the actual Lambda is going to be waiting for the device to publish the latest message. It's going to pick up the message that's already there. The messages are retained in the broker by the broker, so I'll see that message. There'll always be a message, and then Alexa returns and speaks the response. The way Alexa speaks the response is, of course, your Lambda function here is returning a string, which is the words you want Alexa to speak. That goes back here, and then that speech is converted to audio. That audio file is sent downstream, and then Alexa speaks. So it's all happening pretty quick, but it does happen. You probably noticed in the first time I accessed Alexa in this bit on this presentation, it took quite a bit of time, and that's because Amazon Lambda, the Lambda kind of goes to sleep, as in it's not kept active beyond a certain period. So that first time kind of firing up the Lambda itself took a bit of time. That's why there was a delay there. So that's another thing you want to be aware of. If you want to keep this Lambda alive, you probably want to ping it through some other service to make sure that Lambda is kept alive so the response times are faster. But in my case, I've not had that issue. Then ancillary to all of this, controlling Alexa or controlling the microcontroller via Alexa, I'm also using some other features from Windows Azure, where I have a worker role that subscribes to this topic, which is the same topic that the settings come from, or the status comes from. And then this worker role is extracting certain pieces and logging that information to Azure Table Storage. And it's also keeping a track of the state of the device, as in appliance on or off, air conditioner turned on, and or it was on, it turned off, or it was off, it turned on. It's maintaining that state, and every time the state changes, it uses Azure Notification Hub to then send out this notification that we've been seeing on the bottom right of the screen here. So that's I'm hoping this would help you demystify or understand clearly what's really happening. You should be able to see from here that you can use Alexa and this Lambda function. So once you're in the Lambda function, since you're purely in the sort of the HTTP world, you can do pretty much what you want to do with your data, the information or the parameters that came across to you from Alexa. So, like set the temperature to 67. So of course, the parameter is temperature and the value is 67. You can use that information just like any other HTTP request and do anything you want. It doesn't have to be an IoT device. You can say, go read my database and return this information like a query response, or insert data into a database depending on what you're trying to do. So that, as long as once you understand that the mystery sort of sits only here, once you've left this point and come into the HTTP realm, it's just an HTTP application. It doesn't have to be a Lambda function or an Azure function. It just has to be an HTTPS endpoint. That's it. So what you do in that endpoint is up to you. If you want Alexa to speak a response, then of course that HTTPS endpoint you have should return the response in the form of a string or something. Yeah, well, it has to be a string. And then that string will be converted to an audio, and then you'll see the response coming here. So that's essentially how this all works. So now let's look at behind the scenes the model or the language model that we have in Alexa. Actually, before we do that, let me take you to like a bit of an animation that might also help clarify the flow here. So you have an Amazon, let's say Echo device or a Echo Dot device, and you speak something in there, and then that gets sent across to the Alexa interaction model or Alexa skills interaction model that does that processing of the audio into some form of data. And then once it's figured out what was being said, it sends that data in the form of a large XML document to in this case AWS Lambda, but it could be any other HTTPS endpoint. What you do in that Lambda function is up to you, or the HTTPS endpoint is up to you. In this specific case, in the case of the thermostat, it sends out a message to the MQTT broker. Now, MQTT is a TCP-based device, so it's not HTTP or HTTPS, it's TCP. You can have the TLS encryption as part of the transport layer security, and you can also include authentication with the broker, so you can have certain credentials that will be required for you to talk using to be able to connect to the broker and send and or subscribe to messages. And of course, along with TLS, you get the secure transport. The broker, of course, needs some subscribers, so you have your IoT device that's in this case one of the subscribers, and as soon as the message is received by the broker on a topic that the device is subscribed to, you see that the device receives the message. The device then potentially it reacts to that message, and then every 5 seconds is sending a message or publishing a message to a different topic in the broker. And you then have, in this case, the phone application or the UWP application that's a subscriber to that topic that receives that message and then shows that information there. And similarly, the phone application can publish its own messages to the, let's call it the command topic, when you change settings using the phone application, and it's the same topic that the Alexa device is essentially publishing to, indirectly of course. And so whether it's the phone application or Alexa in this case, as far as the device is concerned, is simply receiving messages on a specific topic, of course in a specific format that the device understands. And so the device is sort of agnostic of the mode of input, whether it was a phone application or Amazon Alexa or any other form of application that you might want to build that publishes the correct messages in terms of the format of messages to the specific topic that the IoT device is subscribed to. Hopefully that the animation kind of makes things a little clearer in case the previous slide was not clear. All right, let's look at the Alexa Skill Builder. So in Alexa, it's called the Alexa Skills Kit. In other words, every time you add, when you want to augment Alexa's capability, you're really adding an Alexa skill. So once you have an Alexa skill, then Alexa knows of the skill, and then therefore she can work with that skill. The skill essentially has what is known as in Alexa lingo, they're known as intents. Think of these as the operations or the methods that you want to support in your skill. So in my skill, I have decrease thermostat temperature, get temperature in zone, get thermostat settings, get thermostat status, increase thermostat temperature, set thermostat intent. So the set thermostat is like all the different settings. Set thermostat mode, set thermostat temperature, set thermostat zone, turn appliance on or off intents. These are all the different intents. Now, if you look at the intents themselves, each intent has one or more what we call utterances. This is the different ways in which you might want to interact with Alexa or with the skill, as in you're trying to make this more natural language, as in the more natural way of interacting with your devices or your database or whatever you want to control using Alexa. And so you would potentially have different ways to say the same thing. So let's look at this one here. It says turn this on or off is let's call it a parameter. They call it a slot. So it's like a placeholder, and the name of the placeholder is on and off. That's just the name I gave it. And then this is another placeholder or a slot, and the name of this slot is appliance. So think of these as the names of the parameters. So on or off being the name of the parameter here, and appliance being the name of the parameter for potentially the appliance. And in this case, both of these are lists. So if I look at the appliance slot here. It's really a list of appliances that I've defined, and the list of appliances and other lists are here. So if I look at the list of appliances, I have these different appliances. There's AC as two different words, two different letters, I mean. Then fan, air conditioner, heater, and AC as a single word. So, I mean, if you end up saying AC, she might think of it as two separate things, versus if you said AC, it would end up being one word. Or you might want to say heat or heater. So these are the different recognized appliances. Of course, heat and heater are the same, but I found myself sometimes saying heat and sometimes saying heater, so I decided, I'm just going to define that in the list here. So when you have an intent, the intent has various slots, and then each slot can be configured to have a list. Some of them are predefined lists. For example, the temperature is an Amazon number type. This is a predefined in the Amazon Alexa skills, so you don't have to do it yourself. Amazon has multiple, or just a lot of these predefined slots you can use. In my case, the only slot I could use from Amazon directly was the temperature, but they got like days and month and time and a bunch of other things that can get pretty complicated to define. In my case, I don't have the need for that. I've also defined these two slots or parameters, let's say, to be required. And of course, when you say they're required, you have to go through some additional steps to ensure that if Alexa did not get that parameter, then she can ask you verbally that, hey, can you tell me what zone you meant or something? And then, so there's the extra sort of model design required there. It's not required to have required. It's not essential to have required parameters, but I've defined those. And if you look at the utterances here, they're just different ways to say the same thing. We don't, as humans, don't always speak the same words to say the same thing. There's just different ways to say it. In some cases, just the articles are missing. So in this case, this is turn on the appliance versus turn on. So I could say, ask Alexa to turn on the AC, or I could say turn on AC, and I won't say the. So but you have to account for that. Or I might say switch on or off instead of turn on or off. And then sometimes you just say turn AC on instead of saying on and AC. Right? So you're saying it kind of backwards. So turn AC on, turn air conditioner on, turn heater on, or turn on the heater. Just different utterances. And the specific intent also supports this other way, where I can not only just turn on and off the appliance, I can also tell it what temperature and zone I want, or what temperature and zone. So it just makes it convenient. So this is something you want to sort of play with. You'll sort of spend a lot of time initially working out the different utterances that you might end up saying, and they were not recognized initially. This is what I was doing every time Alexa didn't understand what I was saying. I said, okay, so what did I say this time versus what have I put in the model? And then I'd come in here and add more utterances to sync up with the kinds of things I'm saying. Or my wife would say, hey, I said blah to Alexa and she didn't respond. So she'd give me the utterance she uttered, and I would come in and add it to the utterances for the given intent. Once you build up your model and the different slots, you save the model and you build the model. Now you may get some errors here at this stage where maybe you've done something wrong. Like say, for example, if you marked a slot as required, but you didn't then fill in the other aspects, which is, okay, so if Alexa did not get that slot value, what does she tell the user, saying, okay, so hey, I didn't get the zone. What zone did you mean? Or what temperature should I set it to? Because she didn't get the temperature part in your original utterance. So if you didn't do those things, they just mark these as required, then the model will not build. It'll give you an error. It won't necessarily tell you exactly what's wrong, but you'll have to kind of go through and figure that out. Once the model is built, that pretty much takes care of the whole Alexa side of things, because you do have to configure your skill to talk to that HTTPS endpoint, but that's just a setting. Now let's move over to the Lambda function aspect. So I feel that the Amazon sort of developer experiences are nothing like what Microsoft provides. So if you're expecting to be able to do right click in Visual Studio and do deploy or debug your application remotely, that's not going to be here, not going to be available. And as I said, I'm using Node.js for the Lambda function. So of course in Amazon Lambda you can have multiple functions. In this case I have this function called Thermostat, and on the Alexa side I've said I want you to call this function. So now we're here. The Lambda function, in this case being Node.js, it starts with, and there's an SDK provided by Amazon. Essentially you think of this SDK as kind of the dispatching mechanism. So your Lambda function gets called with this XML document. Embedded in the XML document is what intent that Amazon Alexa figured out that you intended to execute, and all those parameters, the slots. So the SDK is essentially dispatching using that XML. It dispatches to the right function. So in this case I've got a function called set thermostat intent, or set thermostat mode intent, or set thermostat zone intent. So the SDK is essentially dispatching to the correct function here. And once you come into the function, so let's look at that, turn on an appliance on or off. So if you said Alexa asked thermostat to turn on the air conditioner, that's the turn appliance on or off intent. And then it comes to your Lambda function, and the Node.js SDK for Alexa will then dispatch to this function. So once you're here, you can extract the information that you're expecting to find when you hit this intent, using again parts and pieces of the SDK. So in this case, this.event.request.intent.slots, and then the name of the slot and then the value of the slot. Of course, this is JavaScript, so things are dynamic, and you may or may not have a value there. Maybe you misspelled the word appliance and you'll never get the value there. So you got to be careful of some of those things. But the idea here is that basically the SDK is helping you parse that XML. So in the HTTP world, an HTTP request is being made to your Lambda function. That request contains this XML document, and the Amazon Alexa SDK is essentially parsing that XML document and then figures out which function to call and then dispatches to that function. And once you're in the function, you have to extract the parameters that you're expecting to find when this function is called, and then you get those values. The values are of course what Alexa sent. So however it understood your language, and it has parsed that audio file into parameters or information data. That's what you're getting over here. And what I've done is, because you can't debug this kind of on your desktop, and I typically in any other application, let's say I'm building a web application or a web API application, my controller, that's all it does. It extracts or harvests the data from the HTTP aspect, converts that into C# aspects or data types, and from that point forward I just shuttle it off to my the domain logic. So in this case I've got this one class which is like, let's call it the domain logic, that has, I call it thermostat gateway. This JavaScript class essentially is doing all the work of talking to the MQTT broker and figuring out what to say to the MQTT broker and on what topic. The index file is the the entry point in the Lambda, and I'm just using it to help so that I can use the SDK to dispatch to the right function and then extract the data. Right, so that's all I'm really doing here. Once I'm in the thermostat, then I forward that information to the thermostat's method. In this case, the method is similarly named. So it's called turn appliance on or off, and it gets these parameters here. And this uses, this is a asynchronous, in this case using callbacks. And so there's the then and the catch. So if once I successfully call this method, it then sends back a speech output, a text output in the form of the speech output parameter. And the speech output is of course being returned by the method here. So this code base here is simply harvesting the information from the Alexa model, calling a method on this, and then whatever this method returns is returning that back to the caller. In this case, again, the Lambda function was called by Alexa, so the Alexa language model gets that response back. And this is just in the case of an exception. So of course I'm on the methods here, I'm raising exceptions, so in case something went wrong, the part here, the catch portion, will be the one that gets returned to Alexa. So if I look at the thermostat gateway class, this is a regular JavaScript class. I'm using TypeScript here, so it's actually a lot easier to work with classes and interfaces and enums and stuff of that nature. And it's strongly typed in that there's no ambiguity to the extent that you can help it. When you're using TypeScript, you get that C# kind of strongly typed feeling with navigation and debugging and all of that features, just like you're used to. And let's go into the turn on or off appliance. So here's the same method in the thermostat gateway class. Now, rather than making these parameters strongly typed, in other words, let's say temperature, why would the temperature be a string? Why not make it a a double or of course in JavaScript number type? And the reason was that I found I had to what I call normalize this data. So the data comes to you in a certain format, but it may not be all exactly how you want it. So rather than having that logic in the index.ts file, which is let's say call it the controller area, I'd prefer to have that logic in my domain logic. And so when I get these parameters, they're all as strings. And in this case, I'm using promises. So this is the new async await support in JavaScript. So it's got the async here, and so in here you'll find the await. It's very C# style, C# like. Because if the libraries you may be using don't support async await, then you have to kind of do the lifting or conversion between async await to promises. In which case I have to do that here. So which is why this method returns a promise. All of these methods return a promise, but that's sort of orthogonal to this conversation. So I normalize the data. Let's look at some of these normalizers. So let's look at the appliance normalizer. So given some string input, I want to normalize that and return a specific string output. So if I get AC in the form of a lowercase or AC in the form of uppercase, or A and C, two separate letters or words in this format, I really want, or the word air conditioner, either ways, I want to normalize that to this. And that's what I call kind of normalizing. So depending on how you speak, you might get AC or air conditioner. But of course, in my code, I only want to respond to one kind of way of saying it. So it's air conditioner. Same with heat or heater, it's heater. Fan, of course, is fan. And of course, if there's anything else, I don't know what it is, I'd throw an exception here. And then Alexa will say unrecognized appliance, etc., etc. So this is the response that eventually you'll hear Alexa speak. So I have various normalizers for the various different parameters or data types, parameters that I have in my gateway methods. And so I do that. So I normalize them all here. Then based on the logic required for that intent, I determine the message I want to send to my message broker, to that, let's call it the command topic. So then I publish that command to the broker, sending it that message that I've somehow figured out looking at the logic here. Publish the message, and this is actually, since I wrote the other method here, is using the async await, so I can literally do it in the next line. I can say the return the speech output. So when I publish the command, if everything works, I return the speech output, which was defined here itself. So if everything works okay, then the speech output is nothing but something I've defined here. So I've set the thermostat mode to off, and I've turned on the blah. I've turned on the blah at blah temperature in the blah zone. So all the meat of the logic with regards to my thermostat is here. This class can be used independent of Alexa or Amazon Lambda. I could use it anywhere. So once I have this logic now in this one class, I can use this from a web application, a browser application, a Electron application. It could be running in Amazon Function, or in Azure Functions, or Amazon Lambda. The changes would then just be this entry point, let's call it like the controller, if you will, that changes from Amazon Lambda to Azure Functions and what have you. Right, so, and then this helps me debug this as well. So I've got a app.ts file where I've got these functions that indirectly just call into the thermostats methods, so I can test. Okay, so let's look at debugging this application and seeing how this would work, and see it interact with the device here, and potentially the phone application. So if I look at this method here, it's calling into this method, which is setting the heater on, and it's not specifying a temperature. Just say, turn on the heater. So let's run this and put a breakpoint here, and put a breakpoint there. Run this. So this is the Node.js console application, and run it here, and you'll see if I step, you'll see that these values are, there's no zone, the temperature is set to 0 by the normalizer. The actual data that came in was a blank. The actual data that came in is a blank. The appliance here is heater, but here it becomes uppercased or Pascal cased. And you move through this, you should see, now of course this is a heater and it's been set to heat, but the temperature is hotter than the set temperature, so the heater itself won't turn on. So let me change this to the mode to cool again, or off, let's say. And the light goes off, the notification should come here. So that's the notification. So now let's run the JavaScript application again. And notice in the console window, you're seeing the words that you want Alexa to speak. So she would say, I've turned on the heater. That's part of your application's response back to Alexa. So run it this time, and you should see the and again the heaters come on, and on the phone app heat's on and the notification comes in. So in this case the JavaScript class is actually doing all the work, and again the Alexa aspect is simply just parsing the language into method calls and parameters to those method calls. And so I'm able to test out this JavaScript application without requiring the entire Alexa infrastructure on my desktop. And I've seen some places where some people have figured out another way to do this, but rather than messing with the dispatching of the XML to specific methods here, I'm not doing this part over here. I'm just working with the thermostat gateway. Anyway, that's just a implementation detail. Conceptually, I'm hoping you understood how or what it is you're doing in the Amazon Lambda versus what you're doing in Alexa, and so on. So this brings us to the end of this demo. Let me know if you like to see more of this or go into details, and or if you have any questions, then you can let me know what those questions are. Thank you for watching, and I hope you enjoyed this presentation.